Alright, so here is a problem about escape velocity. So, but before that, can anybody tell me the formula for the escape velocity? Or VESC? Anybody? What have you taken notes on this task? Yes, Abdul Wahab?
Mr.
Square root, mister.
Square root of?
2g m
Okay.
over r.
Alright. Where M is the mass of the planet and R is, what is R?
The radius.
Alright. It's the radius of the planet. And G is gravitational constant. Gravitational constant. Now, the problem on slide 50 reads, if the escape velocity on Earth is v, what is the escape velocity on a planet that is twice as massive as the Earth with 4 times the radius? Express your answer in terms of v. So this is a multiple choice question. We have A, B, C, and D as our options. So we have a planet whose mass is equal to 4 times or twice as massive as the Earth. So meaning the mass of this planet is 2 times the mass of the Earth. And the radius of this planet is equal to 4 times the radius of the Earth. Alright, we know also that the escape velocity of the Earth, or V, let me just call that V Earth, as given in the problem is V. So we need to solve for the escape velocity of this planet. Now recall that escape velocity, once again, is VESC is equal to the square root of 2g m over r, so that this means that the escape velocity of the Earth, which is equal to v, is just equal to 2g, the mass of the Earth, divided by the radius of the Earth. Now let us apply the given to solve for the escape velocity of the planet. So then that is equal to 2g, the mass of the planet, that should be the mass of the planet, divided by the radius of the planet. And according to our given, the mass of the planet is 2 times the mass of the Earth, so I'm gonna have 2g. The mass of the planet is 2 times the mass of the Earth, so I'm gonna substitute 2me, divided by the radius of the planet, which is 4re. So I'm just substituting the following. MP is equal to 2me, and my RP is equal to 4re. I will substitute, I would simplify this further in such a manner that I will be able to isolate the factor by which the escape velocity of the Earth changes. So then I will have the square root of 2g. As I simplify this over 2, so I'm gonna have 2g me divided by 2 re. Now this 2g me over re is in fact the same as this one. So then I could rewrite this equation so that I'll be able to isolate the factor. This is just similar to the square root of 2g me over re multiplied by the square root of 1 over 2. They actually are the same. And once again, this square root of 2g me over re, this quantity right here, is actually similar to the one that I have there. And that is equal to v. That is equal to v multiplied by the square root of 1 over 2. Or, if I would simplify this further, that is just equal to v over the square root of 2.
Mister,
Any questions? Yes.
we can't cancel the two together
What do you mean, which 2?
in this step. 2GME over 2RE.
You don't cancel it, because if you cancel it, you would not be able to go back to the original equation, this equation. The idea is, when you're solving problems like this, you must always make it a point that you go back to the original equation. Then you would know the factor by which the original equation changes. Do you get that?
Yes.
Because if I would cancel this 2 and that 2, then I will have the square root of GME over
Yes,
RE,
it will be
which is not the
another
same
equation.
as this. So that's not the
Yes.
original equation. We need to determine the factor by which the original equation changes. That's always what you need to do if you are asked to solve problems like this. Any other questions?
No, mister.
All right, so now that we have determined the factor, which is square root of 1 over 2, or square root of 1 over 2 is actually just equal to it's just equal to 1 over square root of 2. So the correct answer here is D. Any other questions? All right. So kindly take a screenshot of this, and I'll also be posting an explanation to this problem on slide 50. For now, you may proceed with the task for the next period.